there will be no real non-controlled currency in the world.
We're coming for you, banks.
Listening to different podcasts, like in a whole different reality, which they think completely different things about Bitcoin.
They have got my money in their banking system. I should be able to access it, right?
Apple is live.
There's a good number of fucking, pretty smart Bcashers.
Hello and welcome back to the Bitcoin Cash podcast. Following Bitcoin Cash on its rise to global reserve currency, this is episode number 149, 2026 chip proposals featuring Jason Dreyzehner, the one, the only. Today is Friday, the 2nd of May, 2025. I'm your host, Jeremy. Jet is doing the producing. It's the month of bliss, so everybody get excited for that. Quick check on the price. BCH USD $379.92 for 100 megasats, up. One BTC SAT buys 257.1 BCH SATs, also up slightly. One ETH 488.9 megasats, up slightly. Selene 30-day users 1,113 users. We're now into that fourth order of magnitude, which is really nice to see. And the Tokenaut TVL is at 29,562 BCH. Prices up about 4% today with the bank run yesterday. Story for another time. And one thing quickly that we're not going to touch on this week, but I have a slide here with links if you want to get into all of it. It's both excellent and terrible timing, which is that the BTC community seem to be going into a full-on civil war with some massive drama as Peter Todd has tried to fast-track a change to op return filters in Bitcoin Core, which has led Bitcoin Mechanic, after being censored, to lead a counter crusade as he slowly relearns all the lessons that Bitcoin Cashers already know from the block size war. So we're not going to cover it all now, but there's links on the slide if you want to get all into the detail of that, and also a meme of the week that you can just show here, Jet, that is also just quickly a bit of a summary. Essentially, they're just rerunning everything that we have already figured out. Okay, so our guest today, Jason Dreyzehner, is the LibAuth, ChainGraph, BitAuth IDE, and developer, and also Cash Tokens, VM Limits, Big Ints, and all the 2026 chips author. You know him and love him. And special reminder, if you're feeling confused or not following what's going on, that's the feeling of learning. So just let it wash over you and listen to it a second time if you need to. Okay, Jason, hit me with it. Loops, let's go.
Thanks for the introduction. So there are a few proposals on the table for 2026. Loops is by far the oldest. It's a proposal from 2021. It was depending on VM limits. So if I can step way back and give a quick sense for if you didn't follow a lot of the stuff with VM limits last year, the upgrade that deploys in 2 weeks it closes the saga of Bitcoin caches, but Bitcoin as well, virtual machine limits. So the script system that defines how funds are held in addresses in Bitcoin and Bitcoin Cash has this virtual machine model that Satoshi added from the beginning, and it's a critical part. Definitely kicked off the explosion in the smart contract development space. It was kind of the first flare there, and is critical for a lot of trustless applications of using a cryptocurrency. You need to have, if you want to not have an intermediary that is enforcing escrows or enforcing time delays, if you want to have, if you want to minimize the trust requirements of your currency, you need to have a contracting system that allows the currency to execute those contracts rather than leaving it to a custodian or a trusted party. So right in line with the first paragraph of the white paper, where Satoshi was trying to develop a peer-to-peer electronic cash system that didn't require so many trusted intermediaries. A big important part of that in his vision in the early days and on now has been smart contract development where you can write an escrow strategy or a time delay strategy for how you hold your funds in an address. And that allows you to do things like essentially multi-factor wallets where you have a phone and a laptop, or you have a phone that can spend the funds immediately, or if you have a larger amount of funds you want to spend more than $1,000 worth of Bitcoin Cash, you need to have 2 devices, or you need to wait 30 minutes or something like that. There are lots of useful and important uses of currency where you can eliminate trusted intermediaries by having a contract system. So anyways, the original contract system had essentially no limits. It allowed for the tech savvy, it allowed arbitrary precision arithmetic. It allowed the limits. The only limits that were meaningfully enforced were actually enforced at kind of the messaging layer of Bitcoin. It wasn't even enforced over the virtual machine. And for the first year and a half of Bitcoin, that is how it worked. And essentially, no one had messed with it, and Satoshi had barely even mentioned it to anyone. It's unclear whether or not many people really reviewed it in depth until mid 2010. But essentially in 2010, Satoshi switches into, before disappearing near the end of the year, Satoshi switches into a patch and fix any possible vulnerabilities mode, where he's going through and essentially sneaking in patches left and right to harden Bitcoin, and at a time when later near the end of the year, there was some political movement with WikiLeaks in the global press, and Bitcoin got a lot of media attention throughout that year. So it became suddenly very urgent that he go back and start fixing some of the denial of service issues and potential ways that the network could be griefed or taken down. So that was kind of the context for most of the year. And in the middle of 2010 or so, some of the community members who are starting to really take part in development start asking on the forums, what's the script system? How does this work? What was your idea here? And then there's a flurry of activity, mostly from Satoshi, where for about a month there's a little bit of discussion with those developers. There's probably some side discussions over email and stuff that were not in public. And then about a month later, Satoshi completely overhauls how the script system does limits. So initially, the script system had almost no limits. Its only real limit was that it didn't have loops. And I've said before that I think this is sort of an indicator that at the very least, Satoshi did not work with anybody else on the script system. Because if he had explained this to another developer, the very first question would be, how does that help? It appears that he took a very kind of academic approach to this. And this was at a time when we didn't really have a good sense for how this consensus stuff would work over the very long term. He's trying to design a system that works for hundreds of years. On computers that have only been around for half of that, right? Or 100 if you count mechanical. But he's thinking about what are the timeless aspects of the protocol? How do we make this as timeless as possible? And he lands on essentially, well, if we can define the language in a way where it's not possible, where it's not Turing complete. Well, then problem solved. And unfortunately, computers exist in physical space and time, and they have physical limits. So making the language Turing complete is not a meaningful limit, as they rapidly discovered in mid 2010. There are lots of very short programs that could crash nodes. in practice, you need to have meaningful limits around memory usage. You need to have meaningful limits around actual computation. We could even say that he probably had a little bit of a sense that that the same thing that where peers are banned in the current network to prevent abuse might have prevented abuse of the script system as well. But that's not exactly that doesn't work in practice, because the people sending the transactions are not necessarily the people that mine those transactions. So I think fundamentally there were some disconnects in the logic there. But anyways, he discovers that his original approach to limiting the virtual machine was wholly inadequate, and at the same time, probably as a few other kind of community contributors who were contributing a lot of that time, discovered the same thing. So about a month later, he overhauls the entire thing. He disables a bunch of opcodes, adds a bunch of limits around memory usage and how much compute can be used in various spots. Later, it adds limits to signature checking and proximal limits to hashing based on how many operations can be used. All sorts of limits all over. And actually, he has one patch that like adds a bunch of limits, and then literally 3 days later, he changes a bunch of them, adds even more. So he's clearly in like emergency fix-it mode. Yeah, big changes over the course of 3 more days. And he probably rushed out that final 3 days patch because it was the day before the inflation bug, where something 180 million Bitcoin were produced in a block fork because the validation was not correct in the client versions at the time. So the fix for the VM limits was snuck in like a documentation commit right before the fix for the inflation bug. And the fix for the inflation bug is a nice little clean patch. You know, lots of people looked at it. Very few people looked at the commit before, which was like, you know, something's changed an XML file. You know, it had I think it had XML in the commit message, and so surely a lot of people didn't look at all. But he goes through and fixes a bunch of other things, and then near the end of the year is when he disappears. So when he's sneaking in these changes, he's of course not, you know, documenting necessarily how his model, his perspective of the architecture is changing. But something that is sort of funny, that probably had a big effect on the following decade of development, is that at the top of the script file, literally in the C++ code base, Satoshi had a comment that was there since before he released the code base. It's in the code bases that he emailed to other people and stuff. That script is a stack-based machine that does not have loops. And he's clearly, you know, that's his way of saying that, like, that's the limit. that's why it's limited. Yeah. But he didn't go through and delete that comment because it's still right. It didn't have loops. It's just that it doesn't matter. It wasn't important to what was happening below anymore, following a year and a half after the release of Bitcoin. But it is funny because that comment, is most developers' first introduction to the script system. Like, the first thing they would see is either the comment in the file or literally the same comment at the top of the wiki page for decades, you know, for the whole decade. That is, if you ask a large language model what to tell you about Bitcoin script, it will tell you it's a stack-based language with no loops, and it became almost a religious tenet.
Like many things in Bitcoin.
just because the comment was still there, right? And it actually guided a lot of future discussion. There was all sorts of future discussion that, and for good reason. At the time, there was kind of we had a lot less kind of information about how various cryptocurrencies might develop. And so there was a lot more kind of fog of war there of what the future might hold for how the virtual machine should work. And even I'd say like WebAssembly is a relatively new concept, but there is, you know, some alternate reality in which the Bitcoin virtual machine bytecode would have become what WebAssembly is now, a kind of standard cross machine
spec kind of
computational spec. Yeah. And there are of course lots of VM architectures everywhere, but so when you go back and look at the developer discussions around a lot of these things, around loops, and we'll talk about eval and then P2SH, which happened in 2012. A lot of it includes arguments that are kind of downstream of basically people's first impressions of this comment in the code. So it is funny and I would even go a little further and say I think that Ethereum's design may have been slightly influenced by that comment in the code. I think that they made some choices in the gas system that were not necessarily logical choices, that kind of doomed Ethereum to having to measure each operation very carefully, when that was not necessarily like a fundamental requirement of the problem space. It was an assumed requirement because that's what everybody was assuming at the time. And other cryptocurrencies in the meantime have not made those mistakes. So we now have, another 15 years or more now of examples, not just in the splits of Bitcoin, but also Ethereum, and then actually hundreds of other cryptocurrencies that have taken radically different approaches to how they use their contract system, or have no contract system, right? So anyways, some background. So you have to have a sense for why it even became part of the zeitgeist that like not having loops is somehow a feature. It was for a long time, and if you had asked me 8-9 years ago, I would have defended the idea that not having loops was a very wise and prudent engineering decision, and it maximizes the optionality for future protocol development, et cetera, et cetera, et cetera. Hopefully we have, so now with the virtual machine limits that go live in a couple weeks, those limits now have retargeted how the virtual machine applies some of the same limits that Satoshi added quickly in 2010. We very carefully measured exactly the worst cases in all of the various scenarios, and made sure that we could construct a box right outside of those existing limits that allow contract authors to use the virtual machine in very reasonable ways. Whereas before, there were kind of just arbitrary limits that even the 201 opcode limit. It started as the number 200, and then he realized that the postfix plus operator meant that it was a 201 limit, right? I mean, these are these are not numbers that they're numbers that I would say actually clearly he did do some performance testing, because if you actually test the performance of signature checking on the code at the time and compare it against the worst case hashing, they're pretty close. So it's clear that he picked some numbers based on some good benchmarking, but
was there any consideration to making those
on it, right? So
yeah, was there any consideration to making that box bigger, like just briefly? Because like you say, we've preserved the worst case scenario, but in the intervening time, rather than hewing to those limits but optimizing them, was there any consideration to just completely changing the scope? Or
for sure, and people, I mean, for years, and with good argument, people have said like it's silly that these limits are as low as they are. And if you actually look at the virtual machine limits chip, if you look at the risk assessment, there's a section that describes the margin of safety on consumer hardware, and very common consumer hardware. I guess it's been about 6 months for me since I thought too much about it. Actually, I kind of moved on. But I think it was 2021 average consumer hardware or older, and we took a look at for a pretty wide swath of what might be running nodes, and just measured where our limits currently were, and we have somewhere between a 10 and 100x safety margin. So just the validation of transactions at max throughput should not be using more than between 1 and 10% of your consumer CPU on cheap common hardware. And we're talking about like hardware that is truly inexpensive, not inexpensive by even just American standards, like inexpensive by global standards. So so it's certainly, and for good reason, people have been talking, have talked for years about like these limits are silly. We should just raise them a little bit. It's been 15 years, right? But the VM limits upgrade for the 2025 upgrade very specifically and intentionally does not change them at all meaningfully. And it actually reduces the worst case validation performance in one set of very specific abusive transaction types that were already non-standard. So the upgrade itself can technically claim that not only does it for sure not make the worst case validation worse, it actually improves the worst case node operation cost in a few important cases. So yes, we could have increased the limits, and certainly future upgrades could. I am not proposing anything anytime soon. I'm kind of done.
Yes, just for curiosity's
we'll talk about
sake.
these other chips because they're
Yes.
like things that I, in some ways, feel obligated to now at least propose and get started because there's just once you really have understood the history of why BTC landed where it did, and even why Ethereum landed where it did on the gas system. There's just a lot of misconceptions that we need to power through, and in order to maintain Bitcoin Cash's long-term competitiveness with cryptocurrencies that are not making these mistakes. And they exist, even if they're started by venture capital companies and they're not meaningfully decentralized. A lot of users don't necessarily care, and so do we win those users or not? So some background there. The limits, I would say, to summarize, they definitely walk before they run. I've said that before. Like we've fixed them so they no longer penalize normal, honest contract authors. Before, if you started writing a contract, if it got to any meaningful level of complexity, you are suddenly dealing with a 10 times more complicated setup because you have to start breaking up your computation across multiple inputs, and things get really weird very quickly. And now, if most contract authors will probably never encounter limits, with the exception of if you're doing heavy math, heavy crypto math. But if you're doing financial applications, it is very, very, very difficult to get anywhere close to the limits we've had for more than a decade. So onto the chip. So the Loops chip I proposed in 2021, right alongside the VM limits chip, when I finally kind of convinced myself that like not only had I been wrong, and also much of the community had been wrong about this Loops thing for a while, but that if we could retarget limits properly, that we could very safely add looping constructs. And there are some really important, just simple financial applications that makes a lot more practical. So, the examples on the chip have literally been there since 2021, and they're still probably the most direct, important examples. It's stuff like being able to sum up the number of the value of the inputs that you're getting in the transaction. Right now, essentially, you have to copy paste the code to sum every input, and if you have a variable number of inputs, you actually the size of your code needs to factorially increase, because you have to have one set of code that runs if you have one input, one set of code that runs if you have 2, 3, 4, 5, and it gets every time you have a code branch inside is where it expands factorially. So there's just, but it's almost like it almost requires more brain power to describe the silly effects of having such a gimped language than it takes to recognize that. All right, so our virtual machine limits are this very clear box. They prevent any operation from being used without exhausting some part of a unified limit. There's no kind of control flow structure you can add to the language that doesn't end at the same time as if you had copied and pasted those instructions. So some of the long-term concerns where if you had asked me 5, 6, 7 years ago how we could possibly add loops, because then we lose the connection between length of the program. So other cryptocurrencies are not making these competitiveness mistakes, and so getting to a place where our virtual machine can express a simple idea like check the value of all the inputs and make sure that they're no larger than this amount, which is the amount that was authorized by the time locked withdrawal or something. That should be expressible in less than 500 bytes or whatever it takes right now, if you wanted to have it fully generalized, and it should be like 14 bytes. Yes, getting to loops required. Getting to loops or any change at all to the control flow, to how the program executes, required a very careful stage of making sure we understood the limits that we had, and carefully drawing the box around them, and then specifying them definitively, because the way that they were phased in, the way that you're kind of slipped in there, is that they were ultimately an amalgamation of kind of constants interspersed in different parts of the code base, even some places outside of the VM. And to know what the actual limits were, you had to know things like what is the serialization length of different program constructs, and you have to come up with the worst case performance you can get in 15 bytes, because that's what fits here, and all sorts of it's just kind of if you were designing a system with more than a month and a half, it is not a design choice you would make to have your limits be ad hoc, imprecisely specified, where they rely on encoding lengths and can be changed essentially accidentally. Not the least of which is the transaction, the length of transactions, the minimum length of transactions was instrumental in the worst case validation performance. And it's, most people don't think that those things should be so tightly coupled that you might accidentally not understand them. So yes, the limits upgrade that goes live in 2 weeks very carefully draws that box outside, and instead bases the limits on very hard to get wrong implementation concepts. Every single operation has a base cost. The expensive operations have a slightly higher cost that's based on their time complexity. It's not based on random numbers we made up or whatever. It's just based on the numbers that we already had before. We set the top. We set that as the top and made sure that everything fits within there. And then the implementation itself should be also a lot harder for new implementations to have implementation-specific denial of service issues. So even if the limits were cranked up quite a bit higher, we're still this is not the bottleneck. The virtual machine is not the bottleneck.
Yeah.
But yeah.
So then we got loops. You proposed in 2021, shelved it until the VM limit stuff was in. VM limits is in. Now we've got this on the table as part of a package of 3. We'll go through the other the 2 in a moment, but they've actually already been coded and implemented by Callan in BCHN. right?
those guys.
And I don't know, maybe also in libauth because you have them in bitauth, right? So people can play with this stuff now if they want to, or
Loops has been live actually, and it's been in the next branch for bitauth ID for more than a year now. Funny, there were several kind of chicken and egg problems with the virtual machine limits, and probably that's why it took so long. It took decades. It took more than a decade for any attempt to kind of go all the way through. And other forks of Bitcoin have kind of done it actually in some ways, but in other ways still have some silly ad hoc limits. So like there, I'm very excited that Bitcoin Cash has a really a full solution for the whole problem space. But a big part of that was also thinking about what are the potential future protocol upgrades that would break this model of thinking. And so loops is obviously one of them, but in any kind of control flow structure, not just loops, but function evaluation. And then other changes. There are languages with different ways of branching and things like that. But the limits chip goes over a lot of possible future upgrades, and some of the due diligence for the limits chip was making sure that it was reasonable with loops. So I had to implement loops back, more than a year ago in bitauth ID and libauth. So loops, I hopefully we've kind of covered that. I think
I feel like it's not really controversial. I just want to hit on that as well too briefly. Like, I have seen of these three, that's the one that most people are kind of like, this makes sense. There's an obvious way to do it. It's a good idea. I haven't seen anybody say, I don't want this, or I'm confused about it, or anything. So I feel like this one's already looking pretty solid. Is that that your take?
And we got lots of time. We're way ahead of schedule. I mean, way ahead of past years. As you were saying on the implementation, it's awesome. We have 2 implementations already. We've got libauth, obviously, and that I did, and then BCHN has a fantastic patch. And just as an aside there, in part of the tooling for developing the VM limit stuff was testing tooling and benchmarking tooling. And when I began testing BCHN's implementation, which I've nearly completed now, I'd say like 90% certain that it's good, it's perfect. But I'll note that libauth had one way in which some debugging tooling would make it not quite do the spec correctly, and BCHN did it flawlessly right, the first time. There were no bugs in the first implementation. I ran all 30,000 test vectors. I had not given them to Callan before he gave me the patch. So like there's that was shocking. I had to like break it in a few ways to make sure that it actually, the testing wasn't broken, because like I was not expecting it to just be perfect the first time. But it is kudos to Callan for writing a perfect patch on as far as my I'd say my 90% testing can show so far. We've got lots and lots of time still to review that and there's still plenty of time for people to bring up new stuff that we've not considered and we don't know about. Now's the time to tell us about new discoveries or whatever that we haven't heard in the past 10, 15 years on the topic. But there's still stuff. I mean, it's important to have strong opinions weakly held. The smallest like question or detail can really change the correct answer pretty significantly. So I won't jump ahead and say that it's even that it's not going to be controversial in some way. But so far as I can tell, I don't think it'll be.
You're not expecting any changes, basically.
In part because the VM limits will have already happened. As of in 2 weeks, some of the elements that could be controversial are things that you would have to have had a holistic sense of deciding that you think the base operation cost should be executed in some other way, and
Yes.
therefore loops should work in a different way. I should say the specific structure of loops also, the two opcodes, those are not my invention. This is like this is making our virtual machine work more like a normal fourth dialect, which is like 40 years old. So there are very few strong contenders with a significant history for how we should add loops, and we could add like 3 or 4 other opcodes that would make it even more expressive. But in reviewing them, only if we want to minimize the change and have it be as simple as possible, with just these 2 opcodes, you can emulate all of those other constructions. It's questionable if adding additional opcodes, if you would be able to save many bytes from most contracts. These are pretty darn efficient already. And overall, using by computing standards, an ancient specification means that you can actually like ask a large language model to, fix my contract to use, literally say, fix my contract to use op begin, op until, and it will get it correct. Actually correct.
Pattern recognition.
Because they're ancient. Like you just said, tell it that Bitcoin Cash has this now, fix my contract. So there's a lot of like even kind of user documentation and understanding reasons to choose the 40-year-old loop construction, 30-year loop construction, whatever it is.
Nice.
So probably should move on.
Okay, right.
And I'll also mention I do not, by any sense, consider any of these a package deal. In some sense, I am almost dragging my feet on on proposing them, because I'm very done working on virtual machine stuff. The VM limits was hard, and I feel some obligation to kind of finish the job, because VM limits is like 90% of the effort. Once you have a reasonable strategy for limiting it, just making it work like a normal fourth dialect is one possible solution. And we can talk about that with the function evaluation stuff too. I think you said the next was pay to script.
Yeah, we got pay to script next, right? So that's this chip 2024 12 pay to script makes non-standard pay to script outputs standard, an alternative to the current pay to script hash, which essentially allows you to put transparent contracts on the chain that are sort of readable to everyone, which I guess is going to be quite helpful with the increasing sort of move towards BCH DeFi. If you want a contract, you usually don't want to have to publish, here's the contract and here's some side documentation explaining how to use it. Maybe in some cases you do, or in some cases you want that to be hidden because you only want certain people to interact with it. But in this case, you just want to be able to publish like a public API style, right? Here's the contract, and anybody who can fulfill the requirements just comes in, slots in their inputs, and they're going, right? So tell me about this one.
Yeah, exactly. Yeah, you got it right on. This in part kind of I felt obligated to propose this one also, because I know of 2 or 3 projects for whom they have had to make significant design compromises because of kind of some silly code factoring stuff with how pay to script hash works, and the fact that we can't have raw scripts, even though you're dealing with covenants that are themselves public entities on the chain. So there's no reason to hide the code with pay to script hash, because everybody can see how it got constructed in the last transaction. On a technical level, pay to script has kind of 3 different elements that are the thing that unifies them. Actually, is that there are 3 different ways in which contracts have to do silly things to hash some data and provide the hash of the data and then the data itself, rather than just putting the data itself in whatever spot that we're talking about. And there are 3 places where that occurs. And each time it kind of limits the design space for decentralized applications and covenants, and in important ways that actually end up affecting users, because you have to, in some cases, you have to create 2 transactions. And so now you're dealing with like a possibility where there's a finality difference between those 2 transactions. You have to have error handling, and there's kind of like a time delay, and there's more that can go wrong than if you just have an atomic transaction. And then there are weird things with indexing, as you hit on right away, where everybody can see on chain how the contract got constructed, but there's kind of this silly extra 36 bytes of trash that we push around because of how pay to script hash happens to work, and it becomes hard to keep track of, to index or keep track of the underlying contents of what's inside of those hashes. And it just requires, in some cases, it requires a light client to keep, if these protocols get really big, it requires a light client to keep a gigabyte of extra data or something like that, versus being able to scan easily or something. So there are a lot of places where just because of how the precise limits on token commitment length, and on that we have pay to script hash allows you to use any contract, but we don't have pay to script. It ends up complicating actual user experiences, and in some cases doing so in such a way that contract authors end up changing the design of their system because they don't want to do that. And so it would be better if we fix them. But the unifying thread of those 3 changes is actually like a detail for contract authors. The name of the chip is in some ways not quite covering all of them, but. And I'm open to other names, I guess. But calling it pay to script hopefully gets across the most user visible impact, is that there will be, now it would be possible for covenants to not be hidden behind pay to script hash, simplifying wallets and simplifying some security assumptions, reducing some like liveness requirements for those light clients, and making backups a lot easier in some cases. There's a lot of kind of tangential benefits. One of the things I mentioned also that is informed by my my background. I worked at BitPay from 2013 to 2019, and in doing so, I got a pretty solid appreciation for user experience friction that ends up avoiding serious like user support problems. And if you are wondering why a lot of payment acceptance systems kind of went in a direction of like asking you which wallet you're using, it's because even if it's less than 1% of users, it's still a huge number of users have a terrible experience if they think that they can scan the address and just send whatever their wallet sends when they type the number 10, right? And it goes through a currency conversion and then sends in whatever asset they had selected. It can be, you can end up with these terrible messes that also need to be unwound because on some chains you're paying notable transaction fees that users can see. So there is a real important demand for a way to have contracts on chain decentralized applications that are really hard to mess up, where there's actually a real value in having your contract not have an address, because then people can't accidentally think they understand what's going on and blast money at it. And in the very best case, you've got like some fallback strategy for like refunding them that probably costs some like human verification costs and stuff like that. Or in the worst case, their money is gone, right? So this is an issue on other chains that have generic addresses for some contracts, and then those contracts have to have fallbacks for those situations and stuff. But
so
in
does
our
the wallet
case,
specifically need to implement these pay to script on a case by case basis then, or is that what the templated transactions that Emergent keeps talking about is about, right? That then you would have a library with a BCMR of the main types. Is that right? Or
yeah, both are possible. I'd say in the like the simplest way to think about is that for the most part, it's probably good to continue thinking that, like, yes, your normal transactions will continue to have normal addresses. It's that when you go and click in your wallet, you click a buy button on some decentralized exchange tab that's in the wallet, and it tells you you've got all your transaction details there. You click buy, and in the wallet, you've got a nice little view, and you go through the process, and you're interacting with a decentralized exchange. At no point are you copying and pasting addresses, because you don't need, it's literally in the wallet, and there's a nice pretty UI around it anyways. So the wallet itself, in that case, would, yes, understand how to, first it needs to be able to somehow read from the chain what the state of the decentralized application is. It needs to be able to understand that, show it to a user in a way that is useful. And if you have users who are not super technical, you need to have a really nice interface. So there's no good, like, you can't like, it's unlikely that a fully generalized system is going to have nice enough user interfaces. With the exception of if those user interfaces are AI chats, it's unlikely that a generalized system is going to have a nice enough user interface to rival a custom built exchange user interface.
that's on a per contract basis, though, right? Or a per template basis, potentially
protocol basis. Yeah.
Okay.
Yes, and so people developing specific protocols are thinking about what the user experience is of this, and how wallets sync up, how they contact other wallets, if there's like some sense of aggregation outside of the mempool, or if you blast it all up the chain, and how spend races are dealt with, if you have threading, or if you have like managed threads where somebody is ultimately kind of acting as at least like a spam blocker, sort of, or an orderer,
like a filter.
Yep, exactly. So there's an infinite number of possible ways you can construct this stuff, but I certainly expect the first to market, and probably a lot of the most visible and notable uses of pay to script are not going to have addresses at all, and they will be nice interfaces in wallets that are very carefully designed for that particular protocol, or in a if you're using kind of the wallet connect strategy of a web app, it happens under the covers in the web app, rather than being something that the user is copying and pasting back and forth in different places. So the short answer is both, and probably more. It's like both of those situations, and there are probably others. And yes, it is certainly possible that some wallets will have a custom negotiation schemes for pay to script specifically, and that would be perfectly fine also. But from the perspective of the protocol, it doesn't make any sense for us to force users to add those extra 36 bytes, and in some cases create extra transactions or do extra indexing, when in practice all of that information they're just copying and pasting into the next transaction and broadcasting anyways.
So then this is low risk, except for the case where a developer unknowingly publishes their own contract transparently, that they haven't kind of factored that in, and then somebody rugs them out of the money that they put in there, right? Like, the only risk here, separate to what we already have, right? We already have pay to script hash, so this isn't changing what you can actually do on the chain. It's just changing how you express it. And the only, like, I'm thinking, is this opening new vulnerabilities for people to fuck up and lose their money, basically? And what I can see is if you publish a transparent contract, and you can like self-rug yourself if you don't think it through carefully, but that's why we have test nets, and you can already throw away your money by not being careful if you're a dev. I can't make any guarantees on what you can do if you're a dev, but it's hard to say that any
any upgrade ever is completely safe. But I would say it is the other way around, that pay to script is going to be universally safer because it doesn't have an expectation that you can copy and paste an address and things will work. There's and by design, and it's mentioned in the chip, it's actually a feature of this that companies can use this as a way to avoid those user experience problems. So yes, people can always people can burn their money by sending their money to obviously you can send op returns. You can burn your money by sending it to a script that unlocks with an empty bytecode. There's all sorts of ways to burn your money if you're a dev, but I would say between pay to script and pay to script hash, in a nice way, pay to script hash already did the really dangerous thing of giving people a generic address that you can blast money at and not be able to get your money out. And you don't know until you try to get your money out. That is what we have today. Whereas in the other case, at the very least, you can't blast your money at pay to scripts, not by any easy interface. And
you have to
even
know
for
what
a
you're
developer,
doing.
it's very non-trivial
you have to have built it.
Construct manually.
Exactly.
Yeah.
Yes. And I mean, so then that's going to be interesting because it's potentially going to create sort of compatibility or support issue. I'm going to say issue in quotation marks, where this is by design that you might build something that you kind of only want to support in your own front end and nobody else in the industry is going to bother. But that would be a new case that we don't have things like that now, which I think is inevitable as the chain gets bigger and the community gets bigger. I think that's fine, but it's just an interesting note, right?
And actually, for me personally, I personally envision if, for example, JetX is a protocol that doesn't have any sort of backend entity. It is literally an on-chain only. The order book's on-chain. That is an example of something that you could use. You could use pay to script to simplify implementations and reduce transaction sizes, and that any wallet would be able to implement, so that any wallet would be able to take part in that particular global order book, that it would just be available for any asset that any cash token could have a create market button in every wallet that would just work. And there might be 5 or 6 different popular on-chain order book protocols with slightly different properties, and that would be fine too. And wallets could implement one or more multiple as protocols, not necessarily as protocols that even maintain a developer community. Like once those protocols exist, they don't require a server. They don't require ongoing development. Once you've proven the safety of, once you've formally verified that the constraints match the contracts of a particular order book protocol design, there's certainly a potential future in which a few different popular order book protocols become just kind of global protocols that don't have maintainers because they don't need them. And instead they're just things that every wallet can participate in, or no wallets, right? And
that can just happen organically. People can just experiment and then leave a few loose heads hanging on the old one, start the new one.
Right,
and
exactly. And protocol should take that into account. It should take into account what it looks like to try to maintain liquidity over time with new users coming in and stuff like that. But I certainly expect that. I hope that in the short term we will have a number of great global order book protocols that are just sort of out of the box protocols that are pretty easy to implement in wallets, using a templating system or something, so that if you add that tab to your wallet, you can add a tab that lets you, create a cash token and list it in this global protocol. And there's just nobody else you're talking to. You're just putting the transactions on the chain, and anybody else can see and see that there is a liquidity pool here, or there are open limit orders here for this particular asset, and it was created 13 minutes ago or something, right? Right.
Yeah,
So
I'm just thinking
there's
of it
certainly
from
a potential future where you could create tickets for your event and list them from the same wallet and
anybody
just be
just picks them
done.
up.
You don't have to put them on a website. You just
Yeah,
put them on chain in the protocol, and if
Very
you
cool.
then send people you send people the metadata
contract
for
thing,
your
or they already
token,
have a
and you're
browser.
done.
And they already have a browser inbuilt into their wallet, maybe, that knows to look for those. I'm just thinking of it,
Yeah.
as a Selene dev, right? From
Yeah,
the
right.
wallet perspective.
Yeah, I mean,
that
and you don't even need a browser, even like.
well, as long as you have the transaction templates to know what you're looking for, right?
Yeah, right. Yeah, so it's a different. Yeah, so a browser is like a generalized way to pass around, general computations that are web apps. But
Yes.
if you want to have something that's
In
simpler
browser,
and
like a
constraint-based.
library catalog type of sense,
Yeah, right. Yep.
Right. Okay. Yeah. Because I just think, like, for Selene, for instance, we already have a backlog 1,000 things a mile long, and everybody wants, we want, shareable links, we want cache fusion, we want this, we want this, we want this. And as soon as we have pay to script, it's a good problem to have. It means we have passionate, interested, growing user. But it just means that as soon as we have
add this protocol.
Yeah, exactly. It's going to be off the hook. But that's the sign of a growing ecosystem.
Yeah, I suppose it's a good problem to have. But yeah,
yes.
You can have a very you can definitely have a very different perspective of it if you're on the front end of those feature requests than if you're a user and you just get to see all the nice stuff that you get.
Yeah, it's all fun and games for the users. So tell me then, this one seems like it wasn't as straightforward necessarily as OpLoop. People maybe need a little bit more time to cogitate on it. I certainly have been, but it also seems to be probably not that controversial. I think once people work through it, again, there's an implementation already available for people to try out and play around with. How are you feeling about where we're at with this one kind of coming into May?
Yeah, very similar with loops. That we could still there's still stuff to be reviewed. I have personally reviewed, I would say, pay to script and loops. I'm well into the 90% confident that they are technically the best solution for the problem they outline. But there's I'm still interested in feedback from stakeholders and companies. If you are interested in this stuff, if there's something that we have missed in the analysis here and it changes the equation, then that's important to know. And that can, we still have lots of time, much more time than we've had for any past chips. We still have 6 months of never before have we had 6 months of 2 implementations, essentially battle ready, where we just get to do the due diligence part now of like, okay, is this actually really a good idea? So I'm very interested in hearing feedback still on all of these. But yeah, for loops and pay to script, I think loops has been a super obvious thing that anybody who tries to do contracts ends up fighting with. And so that one is going to have a life of its own, sort of, in how people are like, oh yeah, for sure, just ship that now. But the pay to script, you do have to have encountered the problem. But there are 2 or 3 different teams that I had talked with separately that all were having a similar problem in a similar way. And hopefully we'll hear some of the developments in a couple of weeks, actually. And hopefully at the around May 15th, there are launches planned, and hopefully there will be more discussion about exactly how things would be improved with pay to script specifically, or with some of the changes from pay to script rather. But yeah, so very cautiously optimistic that I think we have a really good technical solution, and also very thoroughly tested and reviewed so far. But also we have lots of time, so please take a look. And if anybody has thoughts that the chip misses or something, I definitely want to hear those. Hear those ideas. Hear the if there's some part of the design space that the chip misunderstands, let me know. But yeah, I'm pretty confident with loops and pay to script, and I think that by and large, again, loops has a bigger audience that is hurting for it, essentially.
Yes.
Pay to script has a smaller audience that is hurting for it, and everybody else is kind of like, "What is this, man?" They're just surprised. They're like, "Where did this come from?" On some extent, I mean, because other people, if you've been working with contracts for a while, you're like, well, it's always been kind of silly that we had to pack everything in pay to script hash, like especially because we have to duplicate everything. But if you're not paying super close attention to that stuff, then it'll definitely seem like it was that it was random and sudden that I proposed.
Oh, well, I mean, that's just the job of a protocol dev, is you're going to have to front run the user requirements in a certain sense. So it's not really that surprising. And I talked to Callan before this episode as well, and he was kind of a similar mind that loops, pay to script. I mean, he likes all of them. But that was also, his take. Loops, pay to script, it's pretty obvious. And maybe I should add this as well, he was sort of, like you mentioned, the higher level cryptography. He was very excited about that. He said, as a package, if all of these, they don't need to be a package, but if all three get through, then that makes BCH very, very, open, or how did he describe it? Like complete or something like that, in terms of being able to compete with EVM on sort of arbitrary computation, including complicated cryptography. And just, well, I guess maybe we can mix this into the next one on op eval. So
good segue.
Op eval 2024-12 op eval function evaluation. So this enables a new op code which compresses BCH scripts into reusable functions. Now, this one has been the most quote unquote controversial of the three. Not that there's any grand controversy about it necessarily, but it's certainly the one that has had the most sort of question marks raised and the most existing discussion. So there is some kind of question about whether this would allow mutable, or there's not a question, I guess, but it would allow mutable code on the stack. Just walk me through this. I'll start a little start where you left off with Callan there. That so once we have our VM limits in a reasonable spot, once we've kind of put out the fire there, so to speak, there are two places that very obviously our contract language lacks expressiveness and makes it difficult to even express not just complex cryptography, but even some like straightforward financial calculations that are common in derivatives markets and common in automated market making and common in strictly financial applications of the contract language. Loops and functions are generally useful programming constructs. That's what it comes down to. And we have a fourth dialect. Our bytecode, our VM bytecode, is based on the fourth family of languages. It is a dialect of fourth that Satoshi extended in some very clever ways and constrained in some clever ways to make it really, really good for expressing concisely contracts, financial contracts. And it still is not adequately appreciated. It's a shame that essentially that no loops comment and the downstream zeitgeist that grew around, and the almost religion that grew around how the Bitcoin script worked. I think that undersold how good of a decision a fourth dialect was for a VM bytecode. It is awesome. It's a concatenative stack-based language is a very good choice for the consensus critical virtual machine that everybody has to implement exactly correctly. It's a very efficient way to convey exactly the kinds of programs that we need to convey. And I mean that in terms of literally just raw bytes.
our bytes, our contracts are necessarily able to be more concise than a lot of other programming paradigms. And so when we can see it with other cryptocurrencies now that have tried based on kind of other families of languages. But what we are missing still after limits is loops and functions. Loops, by missing them, it means that we need to unroll loops. That's where you copy and paste the contents of the loop a bunch of times in order to pretend like we have loops. And then there are essentially certain kinds of computations that you need to run in disparate places in the program. And that's what a function is for. And being able to, and so we can talk a little, there are kind of levels of power in programming languages. It's widely considered that kind of the highest level of power, comes with great responsibility if you can have a lambda defined in code and if you modify code and then run it in the same context, see also Lisp and a number of other programming languages in that category of programming language dialects. But back to where we are right now, if we, because actually over the past year or so, I have been losing sleep and fretting a little bit over over how what happens when we have limits fixed. When we get loops, there's still a bunch of computations. There's a bunch of very normal kinds of programs where you need to do a loop, and then you need to have the same code here and here, and if and somewhere outside of the loop, and you have another loop over here. And if you don't have a way of expressing functions, there is a way to write that program. You can write a giant loop over the whole program and enable and disable certain sections of code as you go through. Once you have loops, actually, I mean, our language is already computationally universal if you count if you count being able to look introspect other outputs and then have the other other inputs and have that input introspect the other one. So technically we're already computationally universal, so anything's possible. But especially when you have loops, it's possible to emulate anything else with the loop. You can do some crazy stuff that is really hard to audit and hard to even kind of reason about. But it is possible to compress those contracts with loops also that you would otherwise use functions and loops for. But they are, for good reason, in the programming world, two different things. It's a good idea to have functions, and it's a good idea to have loops. So anyways, the chip is downstream of me fretting over this for a while. And if you had asked me like a year ago or so, my initial impression, if you had told me like, hey, we should have op eval, maybe 2 or 3 years ago, probably, would have been something along the lines of absolutely not, you're crazy. I have, over the past year or so, been somewhat humbled by the problem, both on my previous opinions on the stuff that's going in 2025, especially arbitrary precision math. I've said before, but I'm probably in part guilty of helping to promote the zeitgeist that arbitrary precision math is dangerous and expensive and stuff like that. And it took me kind of a couple months last year to come to terms with the fact that I was just wrong and that we should have arbitrary precision math, and that and so it's funny that the 2022 chip adding opmol and getting to 64-bit math there were people advocating for 128-bit math, and that would be a little bit better in some ways, but yeah, and it seemed risky in other ways, and going anywhere in between is very arbitrary if you go past 64. But yeah, long story short, I had to come to terms with how wrong I was on big integers and also on my initial impressions of specifically of op eval from the 2011 proposal. And we've got lots of time here, so I'm hoping that we'll get. So now there are we've got good testing over a concrete implementation that we can actually talk about. It's very easy to talk about it when you have running code. We've been chatting a little bit over the past 5 months or so since December about all of the other ways you can do function evaluation. I'm generally very excited that there is I think very, I don't want to say there's very strong consensus because that sounds ridiculous, but a lot of Bitcoin Cash developers are excited about getting functions somehow, and so there's just some the technical approach that we ultimately take. There's kind of a continuum of small and efficient and extremely powerful, or heavier and more opinionated from the protocol side, and less powerful. And there's a whole mix of possible options there, and we need to review them all very carefully and think about what's actually a good idea for the very, very long term. My own takeaway and in December and still today, though Strong Opinions Weekly held, is that looking at the alternatives, it's really hard to justify doing anything more complicated than op eval. Even if I try to find ways to as you said there, the not have mutating code in the course of the evaluation. I still am trying to steelman what the implications of that would be for the very long term. What does that mean for Bitcoin Cash in 10 or 20 years? We have so much more information about these kinds of topics than we could have had really in 2011, simply by the absolute explosion of blockchain virtual machines. Like, there are hundreds of cryptocurrencies out there that have made very different choices, and we can even see how it's impacted their contract development ecosystems. And one thing that I did highlight already in the chip and on the forums is there was kind of, and I don't want to straw man this, but there was this inclination that that making the language too powerful would inhibit or slow down the development of formal verification tooling and of other things that are important for auditing and contract safety and the development of the ecosystem. And there's probably some diamonds in there. But if you zoom out a little bit now, we have more than a decade now to look back and see, all right, how did it go? Ethereum made other mistakes in how gas works and how validation works. But loops does not appear to be one of them, and additional power in the expressiveness of the language, with some exceptions, dynamic jumps. Additional power in the language doesn't appear to have had a significant impact on the things that we thought it might impact. You could have at the time reasoned through a little bit more and said, okay, that's probably not going to matter because most formal verification strategies right now, at least, essentially compile down from a formal spec into the target virtual machine language. But just zooming way out, if you look at Ethereum ended up with a lot of formal analysis, formal verification tooling, a lot of development in that area. If those decisions to avoid increasing the power of the virtual machine, if those decisions were truly technically prudent and wise in the early days, where are all of those tools for BTC? So if some of these discussions,
Well, I don't know about that because maybe just, the BTC devs are not known for producing the best tooling or analysis in general. If they didn't bother to build any, well,
there
in a
is
certain
some.
way, you've
There
got to
is
give
already
them credit
some,
because
and actually,
they work
yeah.
limits very well.
Yeah,
But
and the examples that did get built from the BTC side are kind of a demonstration of exactly why the original arguments there were not correct, because so for example, Miniscript is a language designed to be more easily verifiable that compiles to a subset of the virtual machine instructions, and so therein is kind of a demonstration that at least for that subset of the argument in 2011, time has not been kind to some of those arguments, and that's what I mean to say. So it's not. I'm optimistic that there's interest in getting functions. I am not even personally fully sold on OP-Eval. So like I said, I'm in the 90s on 90% on the other two, in my kind of certainty that we're very close to the right technical solution. For OP-Eval, I'm at like 60% or something. I'm still very much if with good arguments, I would be totally against it, right? So I'm looking for those arguments now and trying to get them into the chip, and not against function evaluation in general. I'm looking for some solution to get us to function evaluation, but it could be anywhere along that continuum. It does not need to be, hopefully people will take the chip as it is, as being a fully concrete example to fillet if necessary, and from it we can at least figure out what the arguments are that matter to us, and make sure that we are at least thinking about the right things when we're looking at like a final technical solution.
yes, I mean, I'll say two things. Firstly, so I asked Callan, and he said he likes this proposal, but his reasoning was because you've built it and we've got it. So he agreed. Like we need something to solve this problem, and so he was kind of like, okay, well, at least we've got a concrete proposal, so we can kind of work from there. So in the absence of a strong alternative, by default, he would be in favor of having a solution versus not having a solution. But of course, the same sort of similar caveat that if there was a different alternative or option, he would of course be looking at that very closely. For my own part, I'm kind of split because it doesn't make sense to me that we would necessarily want to introduce mutable state if we can have everything be immutable, and that works so well in a UTXO and a blockchain paradigm. Then maybe it's opening Pandora's box to put it in there. But on the other hand, I also feel like it's possible you can add it in there. It doesn't mean anybody has to use it. Like people can still only be using it in very niche cases where that's exactly what they want to do, and they want to do. If you want to build a formally verifiable system, you just leave the op-eval out, and especially if you have paid a script, right? There would be no reason that you would need, like, you're not going to suddenly be like, oh shit, all these op-evals are in my contract that came out of nowhere. Like, that's not going to happen. It's only going to be if you put it in there, in which case the risk that you're taking.
On the formal verification front, it's something that it's useful to have kind of just a sense of when you get to a certain level of expressiveness for a language, you can write blobs of code, blocks of code that you can then reason about as a single symbol. And so it's for sure possible. Even it would be really hard to add something to the language that could not be used by a formal verification system, is what I mean to say. It would need to really, really leak information about what's going on under. It would need to behave differently in different contexts and stuff for you to have trouble wrapping that in the kinds of symbols that formal verification tooling and constraint solvers would be using. So yeah, that's but these are good discussions to have in very long form, where everybody spends an hour thinking about their about their text before they send it, right? And these are definitely the things that I want to pull out of the woodwork and make sure that we've really thought about this stuff. But yeah, I will say as a general statement on protocol upgrades, there's certainly, especially in like the business community, there's a lot of businesses are not going to be not going to have strong preferences as to how something particularly works in a technical level, because in reality, it doesn't necessarily matter to their day-to-day business.
Yes.
In some ways, fall entirely on the other side of the spectrum, in that I'm probably the thing I lose the most sleep about is the latent concern that I've messed something small up that my grandchildren will make fun of me for messing up, right?
the Dreyzehner doomsday or something, like you'll get your name inappropriately misattributed for the one mistake you made.
Yes, right. Yeah. I lose lots and lots of sleep over the most minute details of these protocol upgrades. So I fall somewhere all the way on the other side of the spectrum there, versus the much more pragmatic. Like in practice, yes, having function evaluation means that the field opens up for a huge set of builders and developers that are working on different chains today, that could relatively easily port their on-chain verification code to the Bitcoin Cash VM. And we are certainly within a year or two of having that be almost automatable by large language models. Some of the frontier models can already do it very effectively, like shockingly effectively. And it's just going to get better. So in one sense, from if I put on the business and practicality hat, it's like getting some solution for functions specifically, basically deduplicating code that, if you have just loops, it's hard to reason about exactly how much that it would blow up certain kinds of verification, but it's not easy. It changes the problem from being a porting problem to being a porting and figuring out how to deal with Bitcoin Cash's silly loops only approach. Yes. But if you have both loops and functions, there are sets of problems that we can be pretty certain reduce in transaction size from many megabytes to being well into the under a megabyte, probably under 100 kilobytes range.
Yes.
And in many cases, under 10,000 kilobytes.
Yes.
And now you're talking about a difference in fees for like people who are doing zero knowledge side chains, where you can deploy zero knowledge applications to a side chain. the on-chain settlement transaction could be $120 or whatever if it's in the megabytes, or it could be a single atomic transaction that's like less than $1. And that is better than a lot of cryptocurrencies offer those systems today.
Yes.
And if they can issue their token as a cash token, they might choose to use Bitcoin Cash rather than their own layer one, and they get community, they get the decentralized exchange support, they get wallets, right out of the bat. So there are definitely a lot of kind of business ventures that it would be really great if we could attract them to Bitcoin Cash and be really competitive in that space. But yeah, I'm if I take off the practical and pragmatic hat, I'm always, of course, terrified that I'm most terrified that something will be slightly wrong and nobody will notice it in review, and it'll be all my fault. So,
it's like, yes, well, hang on. I just want to sit on this for a minute. So, just to summarize there for the listener, what you're talking about is we could potentially be in a situation we ship the upgrade this year, we get this all sorted, we ship the upgrade next year, right? And so May of next year, in just over 12 months now, we could potentially be in a situation where people in all of cryptocurrency who've already spent a lot of time building on Ethereum, building on EVM, building on Solana, whatever they're doing, can say, wait, BCH is starting to catch on. I'm seeing a lot of people talking about it. I'm getting interested. I have a business. They take their smart contracts and code and whatever that they've written, they just put it through an AI. They say, give me this, but on BCH. And 5 seconds later, it reconfigures everything to work in the BCH system, puts it live, and then their business is running in the BCH ecosystem like that fast. So it's very important that we plan this out carefully and we kind of get it right now, because if we do, then in 12 or 13 months, the exponential growth, like, we'll be ready for that to happen if we can make it happen on kind of the visibility and hype and interest, or the economics, the price gain kind of side, right? That's what you're talking about, yeah.
Yeah, I certainly don't want to overpromise that if we build it, they will come, because obviously
no. Yeah, if we don't build it and they come, then it's not where.
Right. That's the issue. If we don't build it, they're definitely not going to come. But if we have a solution for function evaluation, and it doesn't have to be OpEval, if we have a solution for function evaluation, then that completes the general computing kind of tool set, both for financial math applications and for these more advanced cryptography, homomorphic encryption, zero knowledge proofs, etc.
So tell me, what are the other options then? Just briefly, like, besides the way that you've proposed, is there any solid work on alternatives that might not have the mutable code issue?
So one of the options that we talked about a little bit more, and but it is further left on the power continuum there, where it does allow you to define functions in the context of a transaction. The trade-off there, if we were to call it a trade-off, is if you can't define a function from the context of a transaction, then fundamentally there are a lot of kinds of optimizations you can't make, because if you have to specify it in advance, there are optimizations that you might be able to do. It's actually
in
hard
situ.
to make general statements about it in the abstract here.
Yes, okay.
I don't even know if it's productive, because I don't want to get people to dig in their heels on any particular strategy, and I don't necessarily want to dig in my heels on OpEval too much, because my goal is to get to some function evaluation strategy, and having a really solid concrete proposal now means that there's at least something for people to throw tomatoes at.
That's right, exactly. And I think that's what Alan was saying, and I'm also, again, that's very pragmatic minded thinking, is okay, want to get the best solution you have, but the way to do it is to start with a solution, and then everything at least is iterable against that bar.
Yeah.
Okay, all right. Well,
So
let's not.
but I'll say, let me say, in general, there are solutions where if you're trying, if we do find some good, steel man arguments for why it's important for the future of Bitcoin Cash, if there's some kind of performance or future optionality for future upgrades, like those are still important things. If we find that we want to ensure that functions cannot be defined in the course of evaluation, and go check out if anybody's curious, go check out the forums discussion on just-in-time compilers and whether or not we're trying to compete with WebAssembly, basically. But there are some general strategies. You can do something like op eval, where you push the code and then eval it. You can do something like op define and then invoke, where the VM now has to keep track of a little bit more state, and you push the code and you run op define and you give it a number, and then later you can call that function by giving that number to another opcode to invoke function 1, invoke function 7, 8, whatever. And then there's so those are like in context operations. Of them, op eval, I think, is provably the most optimal, and there are not really many trade-offs between them. There are cases where op define and op invoke would be slightly more efficient, but it takes 2 opcodes. It's hard to take 2 opcodes to save a byte in rare cases when op eval saves more bytes in kind of the long ends of the bell curve. But the other options are, you can define a output level function data structure that in the output you have kind of a list of functions, and then you can call those from the contract, and that is one way to statically define the functions. And you can get that might really be a great strategy. It is quite a bit more complicated as far as from a protocol perspective, because you have a data structure there. You need to have rules around the limits of the data structure. You need to have, the maximum function lengths. You need to know, what's the maximum number of functions. Can you can you have a contract in which you don't call all of the functions? Do we track that each of the functions has been called? Is it but probably not, but it's something that we should talk about. There's there are a number of other things that you need to think about when you get to adding data structures for new protocol features. So one maybe minor advantage complexity-wise of kind of the inline definitions is that the existing virtual machine limits are just fine, and you don't have to necessarily have a separate think about them separately in a different context. But there might be some advantages there for ultimately how simple transaction compilers can be. So that's some stuff I'm still experimenting with, and I hope other people will experiment with. Then, so anyways, output, there's the output function structure. Then there's, on another level, if you have that, you're still, in some cases, duplicating the function bytecode across either lots of UTXOs, which is not necessarily bad, or you're duplicating it in the inputs of lots of transactions. You literally have the same function in lots of transaction inputs and for some kinds of contracts. And there are ways that you can optimize that out of your contract system. You can design your contract system to instead try to have that kind of processing all happen in one input. But then we need to start talking about the 10,000 byte limit is different than the 100,000 byte standardness limit for transactions. So fundamentally, we have right now, even with P2S, even with that chip, there's still the possibility that some contracts will choose to break out their computations across 10 inputs and still maintain their standardness. So deduplication across inputs also is a consideration for that item. And so then you can get levels more complex with having the function definition structure possible to define in inputs. You can have it possible to define in both locations. And if you have it possible to define in inputs, you need a way for outputs to be able to commit to the bodies of the functions. One class of this solution is Taproot. Taproot takes a very opinionated approach, which works probably really well for a pretty large category of transactions. It doesn't necessarily work for all kinds of transactions, but that was not the target. They made a very opinionated approach and said everybody should do it just this way, and this is how you commit to all of the different unseen spending paths. And you can either use a nothing up my sleeve number, or you can start with an aggregated key or whatever. And overall, that's useful. But yeah, so hopefully that gives you a little bit of a survey of like just how complex you can choose to be as a solution to this. Would it be directly applicable if you make it, if you make a much more opinionated solution? How difficult will it be to port different kinds of computations over to the Bitcoin Cash VM? That's a little bit of an open question. On net, it shouldn't be too much more difficult to do anything. Like, we're dealing with computers, and if you're computationally universal, you can anything can do anything. Anything can simulate anything. Anybody can write anything in their compiler and make anything happen. So you can definitely see a possible solution in lots of spots along that continuum. And so in proposing the OP-Val chip, I instead chose to go like all the way to one side on the simplicity and power front.
And then let people negotiate against that.
And you can choose to go as far as you like the other way, with Taproot being somewhere close to the end of the other side.
Yes. Okay. All right. More work required. People will be, thinking about that, discussing on Bitcoin Cash research, and we'll probably talk about it at Bliss, maybe on the technical panel and stuff. But we're running short on time here, so I want to get in a couple more things. TXV5. This is a bit more speculative, right? This is not really in the works or the roadmap for 2026, and it has a big ask for the ecosystem in general. So we really want to be getting some serious traction and having our credibility be quite high before we maybe try and roll this out in general. But tell me again, trying to keep it kind of quick, because I do want to get through at least one or two more slides on this one.
Yeah, for the most part, the TXV5 stuff is trying to just kind of get on the table what I think right now is the optimal design of a next version of our transactions, and it cleans up some things that have been wasteful for a very indefinitely since the start of Bitcoin. So and it tries to solve some long-term problems like fractional satoshis and fractional cash tokens. One part of TXV5, which is one of the most useful parts, actually doesn't require a new transaction format. The read-only inputs, and to a great extent, the zero overhead covenant stuff. You can get some much greater efficiency out where you don't have to duplicate the code that runs contracts. Doesn't end up getting duplicated on the blockchain, and also can be deduplicated out of transactions to some extent. A lot of that is definitely more out there, and it's more for research purposes right now. I wanted to get it kind of all together in one spot, because in one sense, transaction changes, you can't kind of change the transaction format. It's just a change. It's a version change of the transaction format would be a big deal. other cryptocurrencies have done it. Ethereum and Solana have both made pretty big changes to their important serialization messages. So it's more that when if you're below the top 10 in market cap, it's probably unwise to make that kind of change. So yeah, and I've said that I proposed it in the chance that Bitcoin Cash is well within the top 10 probably by January of 2026 of next year. Yeah. So it'd be
that's a bit of an
well within time to launch in, right? So we got some time, but it's hard to envision myself doing the chip process again in 2027 right now. But
that's all right. Maybe somebody else will pick up on it, if they feel passionate about it.
And there's some like the read-only inputs could very well be a much more constrained, backwards compatible, overall very simple and safe kind of change. Probably not for 2026, but for sure for 2027, it would be definitely in the cards. But yeah, for right now, my plan is to let that marinate a little bit and let other people be thinking about some of the ideas there. It's bringing back up some like detached signatures is probably a better solution to at least part of the proposed reasons for SegWit. So that it's something I wanted to make sure that we keep on the table a definitive malleability solution, which also would allow non-push unlocking bytecode, which would unlock some big improvements in transaction sizes. So, and those are things that like you can't reasonably do outside of a transaction format change. So they're just even some very small things I tried to just kind of get in there so that they would be on the table and instructive for future upgrades. And if Bitcoin Cash grew very quickly, then it would certainly be a little bit more important and urgent that we had some ideas already kind of
in the pipeline,
in discussion there, especially things like fractional Satoshis. Like it's definitely not urgent, but we are kind of getting to the time when we need to be thinking about what happens as the subsidy wanes and we transition to transaction fee only model. And we need to be thinking about even super long-term things also that have been more theoretical for a long time. One of those is fractional Satoshis and then on that topic, maybe fractional cash tokens. So.
Okay. All right. Do you have any quick thoughts on like quantum computing stuff? I haven't seen much chat about that. I sort of really want to feel like we want to get at least a bit of chat started about that. Do you have any thoughts? I mean, I guess
not
these
too
upgrades
much, just
also
that we're in a really Sorry. Not too much. Just that we're in a really good position with contract system. That the moment an independent developer wants to run hard on that problem, they don't need to ask anyone for permission, and that's a good position to be in. And that's the position we want to be in with respect to zero knowledge proofs and homomorphic encryption and these other kind of heavier math uses of the virtual machine. We want to make sure that we are capable enough that there isn't a like political and chip step of getting something deployed in order to create a cool product that uses some tech. Because in practice, those companies simply won't build on Bitcoin Cash. They've got lots of other options now. So if we want to be competitive with all of those possible use cases, then we want to make sure that we have the basics. But VM limits, the upgrade that goes live in a couple of weeks, gets us very close on that computation side. And then some of the stuff we've talked about, obviously with loops and functions, would kind of close the remaining gaps.
All right. Okay, cool. And 1 minute blocks, Bitcoin Cash Orders has been cracking away on his chip there, been doing plenty of works. Again, it's sort of more 2027 or 2028 even potentially, but these things take a long time to simmer. What do you make of this? Are you roughly, thinking it's the right direction, or what?
If you had asked me like a couple of years ago, I would say that it was, jumping the shark. It's just like, no, absolutely crazy. But even just over the past year or so, there are definitely strong reasons to look at those constants. Even just looking at how network performance has changed since Satoshi picked a number based on the state of the world. And in the first version, if I recall correctly, it was 15-minute block times, and then down to 10-minute during the actual publication. And that's like I might be completely fabricating that memory, but somebody let me know. But
I feel like he already said. I remember Satoshi said probably 10-minute blocks in the preamble when he was on the mailing list. So
I'm not sure. There have been some big changes since then in how the internet works even. So probably the most notable thing in the context of Bitcoin Cash is SPV mining and headers first syncing together are probably a multiple orders of magnitude difference in potential orphan rates and actual latency between miners. And then there are the mempool synchronization technologies, and that's everything from like Erlay and Graphene and Xthinner and et cetera. And those have, the numbers on those are better than 99% compression, right? There's a lot of huge advances there. And then even the internet itself the latency of the internet itself has fallen in that time, right? The actual ping time, round trip ping time between the US and Japan has decreased notably. I think it's not nearly the impact of those other mentions, but it's something like
it's still a factor at all compounds.
Right, exactly. So it's something. I don't have any kind of certain strong opinions or certainty here, but I certainly don't consider it like out of the realm of possibility. And there are some good there's some good competitiveness reasons to consider it. I have always been most concerned about censorship resistance, and so any solution, if you'd asked me a few years ago, that my answer would have been, probably a knee jerk, absolutely not, and for censorship resistance reasons. And thank you to the people that are working on it right now and slow simmering the research and outreach and stuff. Kind of upon re-examining those ideas, I think what I consider to be critical to the censorship resistance is the credible threat of miners being anonymous when they broadcast blocks. And so there's certainly, and other people are concerned about like orphan rates and impact on fairness for miners and stuff. And that's also very important, but I'll throw in that like one of the things I'm paying the most attention to is I think it's been extremely protective that Bitcoin always, by design, had the credible threat of miners being anonymous. And of course, you can see that, you can go look at a pie chart and you can see which miners claim to have mined each block. But the thing that really protects the system in those cases, assuming you have a wide enough mining ecosystem that people can't just march in and take everything, right? If it's reached a baseline level of decentralization, the system design is important in that it doesn't require a consistent identity for the producer of blocks, because nobody cares about their identity. All they care about is the hash. And so I'd be concerned about anything that jeopardized that property. And a lot of proof of stake strategies do jeopardize that property. They create some sense of identity around the producers of blocks. And I think that we could have had a very different history if Bitcoin was designed like that from the start. That the credible threat of miners going anonymous and winning then in that challenge between kind of a rogue government and the miners in other countries, but also within a certain country, the protective effects of not having an identity in a system at all is really very important for censorship resistance. So I'm very, very focused on that for how the
block time and the mining element,
how that goes forward.
Into it, yeah.
I'm also on the note of things that it's time to solve. There are some fee sniping and fee smoothing need to be considerations in the somewhat near future, and so there's to some extent we need to look at this problem anyways if we're going to safely migrate off of block subsidies and over to transaction fees, and that is an area of research that I think has been like really sorely lacking, and we get a new bump
every
4 or 5 years, but it's definitely been on the back burner. But it is time to think about fee smoothing strategies and solutions for strange mining games as the subsidy becomes less practically relevant for real operations. Right now, we're very protected by the long-term incentives of miners, and miners, of course, are very incentivized and also just socially on the side of the network. But that's not the permanent state of the system if we don't have solutions to some of those strange incentive changes as they begin to happen. So even if we weren't talking about block time specifically, and there are very convincing reasons to be talking about them, and my opinion has definitely changed a bit on the past few years on that. So thank you also to the people doing that. But even if we weren't talking about the block times, it is probably time for us to be talking about some of the other things that are relevant to that discussion too. So I'm excited to see all of that research, and 2 thumbs up, and thank you very much to everybody doing it. I'll
Good
continue
stuff.
watching.
Good stuff. Okay, we've got time for just one more quick one, and then I'll give you a message to the community, but it needs to be quick, and I had to throw this in there. I've been beefing on Twitter with some of the Monero guys about the fact that we're just going to completely obsolete all their privacy contracts after we get VM limits and potentially a couple of these other tweaks through. Any very quick thoughts on that? What we can prep the wallet ecosystem and kind of have everything ready to rock and roll, or what?
There are some peer-to-peer networking things we need to talk about with privacy. I think, and I've if anybody's curious, I've posted on the Bitcoin Cash research forum a little bit about this. That I think people underappreciate just how bad privacy can be on the networking layer. Not when before you think about the cryptography at all, the networking layer and a sufficiently powerful attacker who can just see some significant portion of the network and see the encrypted messages they're sending back and forth to each other. If they can see parts of the chain too, or some of the vulnerabilities in some of these privacy coins, it's very likely that peer-to-peer networking is de-anonymizing a lot of transactions that we think are pretty safe. So yeah, I think Bitcoin Cash has really good practical privacy right now, surprisingly good practical privacy, and I think we can continue doing better with that. And yes, we're really close to being in a place where a sufficiently motivated developer can port anything that's happening even in the consensus layer of other cryptocurrencies, port them to covenants. And when we get far enough along, then we even have an idea of how we could get those to zero overhead, where you have the same transaction sizes, the same bandwidth costs, which are the costs that dominate node operation, the same bandwidth costs as dedicated layer one only, protocol upgrade only, privacy coin solution. So yeah, I think certainly that's in scope in the next few years. I think some of them are possible and will be possible, will be much more possible in just 2 weeks. And then even with the stuff we've talked about, the 2026 chips, there are still places where we set the limits so conservatively that I expect the limit that is going to be hit the fastest. And there's probably a bar where some sorts of zero knowledge proofs and privacy systems will be immediately possible in the most efficient way. And then some will actually require you to break up the computation even more because the limits are so conservatively set, walk before we run, where each operation is essentially gets you close enough to the kind of the cancellation level, where every single operation costs almost as much as we charge for the cheapest hash. Like we were very, very conservative with the virtual machine limits. So I think there's kind of an iterative approach that will probably happen there, that we need to see real applications trying to do the ports and showing us exactly how many bytes they have to waste in order to do it's actually very cheap computations. It's just that they have to do them quickly. And it's very possible that the base instruction cost will go from 100 to 10 or something, which is probably closer to the more reasonable choice anyways. And that can be a very contained upgrade with an on-chain footprint that we can see exactly how it will improve transaction sizes and stuff. But yeah, so with the caveat that our limits are still very conservative, and even with constrained bytecode, you still end up having to break stuff up in order to fit within the computation limits, just because we were so conservative there. There's going to be kind of a line of stuff you can do immediately as efficiently as possible, and then stuff that you still, if that does get developed, it'll have to be broken up into at least multiple inputs, or maybe multiple transactions, and have kind of a settlement process or something. But yeah, I'm definitely excited about where all of that is headed for sure.
Okay, all right. Well, we're going to have to wrap, even though there's a ton of other stuff I would love to talk about, and even any of that in more detail. But you have your message to the community outro slide that we give everyone. You know how it goes. What does the BCH community need to hear?
Well, for the chips, please take a look at those 3 chips for 2026. We've got plenty of time still. In some ways, we are way ahead of where we have been in past years. As far as testing of concrete solutions go, we are where we were in September or October of last year when it comes to VM limits. And VM limits was well ahead of previous upgrades. So we've done better and better each year, and that's over time, and it's before even the chip process. We're getting better at having non-controversial upgrades that are finished and ready and tested and ready to go live 6 months in advance. And these are well on that schedule. but there's still a lot of due diligence that needs to be done, and they're by no means finished. So please take a look and let us know if there are ideas we've missed, or if there are considerations we should make sure are part of the solution. And I'm excited to continue working on it.
Yeah, I mean, being that far ahead of schedule also allows us to be more and more ambitious as time goes on as well too. We can think about bigger things, more things simultaneously, while everyone has plenty of time to adjust to it. And that's going to be really important because the horsepower is also going to ramp up as more people get involved as well too. So anyway, yeah, we're trending in the right direction. Okay, if you are a FundMe contributor, or you want to be, go to fundme.cash and you can chip into the podcast FundMe that we're running at the moment. That's about 2/3 done. And also the Selene FundMe, which is about 57% done to keep funding this enormous pipeline of content and innovation we're trying to maintain for you. Thank you to our existing contributors: Majumali Marcelo, Funding Father, Molecular, the show we love, at Cash Stamps, BCH for the win, Cash Dragon, RealBitcoin.cash, Murray Store, great work, Burner Nakatl, Bitcoin is Cash, Milton Friedman, Emergent Reasons, Stay Grounded, Go Big, Canach, BCH is the Michael Jordan of crypto, and Dora must keep building. You have full support from many, our donators. Thank you very much. Our patrons, Ricky and HP, and our sponsors, General Protocols. Check out bchbull.com. Start guide FAQs. Links are at bitcoincashpodcast.com. If you're new, listen to episode 85 and try Selene at selene.cash or app.selene.cash. And you can literally just try it in your browser. Now that is rocking it. Bliss is in 2 weeks. We're not going to have any episodes before then, but we will be live at Bliss, obviously. And if you're deep in the weeds, you can also get in the mix on Twitter with the BTC hijacking. To the extent I've had spare time recently, I've been stirring the pot a little bit with them too. So always in good fun. The drama never stops, and we will I think have to cover that situation in more depth on the podcast. With the right guest, maybe after Bliss. So everyone can look forward to that. But who knows what the situation will be in a couple of weeks. That's a rapidly developing situation. Okay, final shout outs, Jason.
Thank you to the people who've already given feedback and come up with things that we were missing in the chips. Yes, thanks especially to Callan for getting it implemented so we can have a concrete implementation to kick on BCHN. I appreciate everybody who's been contributing there. Amazing.
Jet. Nothing. All right. And my final shout out goes to Bitcoin Mechanic, who I know is definitely going through a rough period in his life as a result of the drama he's currently in the middle of. I always feel for people going through one of those moments where some of their pre-existing beliefs and assumptions of their model of reality is collapsing, and then that puts you into chaos, and you've got to try and rebuild, find where is the actual solid footing. So he's having a tough time with that, and that's very emotionally stressful and draining. But of course, at the end, you come out better for it, having rebuilt things on a slightly more firm foundation. We'll wait and see to what extent. I don't think he's going to get all the way to BCH is the real Bitcoin on this run through the mill, but he might get significantly closer. So we'll see. All my best wishes to him. Okay, thank you everybody for listening. See you at Bliss. Until next time.
Satoshi's granddaughter says the state won't save me. cash girl. Sanctions and inflation and killing in the news. People literally dying 'cause of money we can't use. Well, she got the tech. She's a superhero breed. Translocate around the world. No bank account free. Now I see some hope. More than just politics and code. She's all over the world. She's my Bitcoin cash girl. She's all over the world. She's my Bitcoin cash girl. Yes, she is. Streamline a virtual machine. Bare metal just like a dream. Such a sexy efficiency. Smart contracts and privacy.